In addition to the standard math operators, addition, subtraction, multiplication, and division, Python has a number of specialized operators, as well as libraries that we're going to be using quite extensively this semester. This video will walk you through those so that you can see how to best apply them. I also want to point out that this first cell here is a Markdown cell, which is extremely useful this semester for you. And that is, it allows you to document and keep track of and describe and take notes right within your Python code. To create a Markdown cell, as a reminder, click over to the left side and hit the letter A, which will insert a cell above it. And then you'll notice this says code. It's expecting Python code here, so we need to change the type of cell to Markdown. From that point on, you can pretty much type whatever you want to in there to keep track of the notes. If you want to create a heading like this one right here, just put hashtags in front of it. And when you run it, you'll notice it uses a darker font and it presents itself as a heading. To delete a cell, just click over to the left and hit X. To use a library, you must actually import it. So if we're going to use the math library, we say import math, and then I can say Shift, Enter, and that will run it. That puts it into the computer's memory. I can hit Shift and Enter again, and that puts in leg 1 and leg 2. I want to show you something else that's really useful. If I click over here on the left side and I hit the letter B, that can insert a cell after the cell. You'll notice that once you have something in memory, the Tab key becomes an extremely useful tool. So if I said, for example, X equals, and I say math dot, that allows me to access the particular methods in the math library. I can now hit the Tab key. All of the different functions that are available in the math library now pop up. If I'm looking for the square root function, I can hit the letter S, and only the functions that have a letter S in them will then appear. I can then hit Q, and again, it filters it even further, and then I can just choose square root from the list. Very, very useful. I'll show you another use of the Tab key here in just a second. For now, let me go ahead and delete that cell using X, and we can go ahead and move on. Again, leg 1 and leg 2 are in memory. I can go ahead now and run, and I can calculate the hypotenuse simply by taking the square root of leg 1 squared plus leg 2 squared. And you'll notice I'm using the square root function from the math library. And if I run this, I will get the result, which is 72.76. Now, once you have something in memory, the Tab key again becomes very useful. I could type out the word hypotenuse, but let's face it, more than likely I'm going to make some kind of a typo. So if I say HY and I just start, I can hit the Tab key and it will complete it for me. Very useful. It minimizes typing errors and it also just keeps you moving and will make things a lot easier when you're entering things. So it's a good thing to know. Another function that's available in the math library is the ceiling function. So let's take a scenario. Let's suppose I need to make 50 cakes and each cake requires 2 eggs. How many dozen eggs do I need? Well, I can do that calculation pretty simply. I can say the cakes is 50, the eggs per cake is 2, and I can just do the calculation. And if I do that and run, you'll see it comes up with 100. Okay, so I need 100 eggs, but that's not what the question was. The question was, how many dozen eggs do I need? Well, if I simply divide the number of eggs by 12, it seems like I might get an answer, but that's actually still not the answer to the question. I don't need 8 1/3 dozen eggs. I need how many dozen eggs? That is, I need a whole number of eggs. I need 9 dozen eggs here. So to actually raise this up to the next highest whole number, I can use the math dot. I'm going to hit the Tab key now. And if I type in CEI, you'll notice the ceiling function pops up. I can hit return. Very useful. And then I put this in parentheses. And now if I run this, you'll see it gives me 9. That's the correct answer. If I go to the grocery store, I'm not buying 8 1/3 dozen eggs. I'm actually buying 9 dozen eggs. The math library also has a number of constants built into it, including pi, probably the most useful one. If I want to run it, I can actually see the value of pi just by saying math.pi, and you'll see it's 3.14. If I want to find the area of a circle that has a radius of 3.5, I can use pi r squared to get the area, and here's the result, pi r squared. If I run that, you'll see I get approximately 38.5. Another useful library is the random library. Random is used a lot, actually. It's used a lot in games. So if you're shuffling a deck of playing cards or rolling a die, that actually relies on random numbers. Again, before I can use any library, I have to import it. So I can shift and run, and you'll see that I have imported now the random library. Now, one thing I want to point out here is that there is one aspect of Python that does confuse and stumps students sometimes. If I want to use, anytime I'm using a range, the Python convention is to actually have the second number be one more than is required. Now look, I know that's kind of confusing. To be honest with you, I'm not sure exactly why Python does this, but it is fairly consistent across the language in its use, and you'll see this actually when we get to the looping statement in a couple weeks. So if I want to return a number between 1 and 6, this has to be 1, 7. And if I put 1, 6 here, it would only return a random number between 1 and 5. So this is the correct statement, 1, 7. If I run this cell and then I print the result, you'll see I just rolled a 2. Now I can run this again, and now I rolled a 3. There's also special math operators. One is integer division. It's not used a lot, but it is used occasionally. So for example, how many minutes are in 7,813 seconds? I can use the integer division operator, which is 2 slashes. And if I do that, this will return the whole number result of this division. Again, if I use the standard slash operator, that returns the decimal version of it. So if I run this and I print, you'll notice the first one returns the whole number version, which is 130. The second returns the decimal result. And by the way, you might wonder why I put the print statements in here when I've only been using the names of variables to display the result. It's a good thing to know. In Jupyter Lab, if you want to print out more than one thing in a cell, you must use the print statement. So if I do this, for example, and I remove the print statements, you'll notice that the only thing that prints out is the second item. You can't print out multiple things without using the print statement. It's a good thing to know. And I'm going to go ahead and put this back, and you can see again, if I put 2 print statements in, both actually will display. Another special operator is Modulus Division. Modulus Division returns the remainder of a division. And you did this actually in grade school. So for example, the modulus operator is a percentage symbol. So as an example, if I said 25 mod 7, what would that result be? Well, we know that 25 divided by 7 goes up to 3 because that's 21. If it went to 4, of course, it would be 28, and that would go over 25. So 25 divided by 7 is 3 with a 4 remainder. So therefore, 25 mod 7 is 4. 14, if I did 14 mod 3, what would that result be? Well, 14 divided by 3 is 4 with a remainder of 2, because 4 times 3 is 12. So the 2 remainder is the result. So 14 mod 3 is 2. If I did 99 mod 79, well, we know that 99 divided by 79 is 1 with a 20 remainder. So again, 99 mod 79 is 20. Now this may seem extremely specialized, but as it turns out, it actually comes in handy sometimes. For example, what if we want to know whether a number is even or odd? Well, we can do a modulus 2, and that will tell us. Any number mod 2, any number that is even, if it's modded by 2, it will actually return a 0. Any number that is odd, and we mod it by 2, will return a 1. So if I want to check whether 54 is even or odd, I can go ahead and run this, and you'll see it results in a 0. That's because 54 is, of course, even. If I said 55 and I run this, the result is 1. So this will tell us whether or not a number is even or odd. Compound operators are commonly used in looping statements, and you'll see this in a couple of weeks, especially within the while loop. It's commonly used in the while loop. The two you'll see the most often are plus equals and minus equals. Plus equals is very easy to understand because it takes whatever is on the right side of the operator and automatically adds it to what's on the left. So this in effect increases counter by 1. While the minus equals does the opposite. It takes whatever is on the right side of the operator and decrements it or decreases it by 1. So in effect, these two statements are equivalent to each other. So why do we need to have this special operator? Well, the answer is actually efficiency. This operator right here runs twice as fast as the second operator. So because of that, a good programmer would never actually use the second because it would slow down the program. By the way, Python also supports the same versions using multiplication and division, but we won't probably use those very often, if at all. So here's an example. Suppose I set counter equal to 13, and then I use the specialized operator and increment it by 1. And then I print the result, and then I use the special operator and I decrement it by 10. If I print this, you'll see the result is what you would expect. The second statement here increments counter by 1, upping it to 14, and the specialized minus operator decrements it by 10, resulting in 4.